Hi students, let us discuss about now the homologous series. A homologous series is a group of organic compounds having similar structure and similar chemical properties, in which the successive compounds differ by a CH2 group. Means these are the different compounds having similar structure and similar chemical properties, okay, and they differ by CH2 groups. The different members, they differ by a CH2 group. Let's have a look at the homologous series of the alkanes. This is the homologous series of alkanes. The first member of the alkane family is methane, CH4. The second one is ethane. What is the difference here? There is a difference of a one carbon. This is C1, this is C2, so difference here is one carbon, and hydrogen atoms here 4, here 6, so difference of a one carbon and two hydrogen atoms, right? So that means the first and the second member, they differ by a CH2 group. Let's have a look at the C2 and the CH3. C2H6 and C3H8 molecule. Again, between these two compounds, between these two successive compounds of a homologous series, they differ by one carbon atom. This is C2, this is C3, so there is a difference of one carbon, and there are 6 hydrogen atoms here, and this one 8, so there is a difference again of a CH2 group. C3 and C4, again the difference is one carbon and two hydrogen atoms. C4 and C5, again there is a difference of one carbon and two hydrogen atoms. C5, C6, again there is a difference of, so you will find this difference same, right? Here, 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 any two successive members of a homologous series of alkane, here we find that they have a difference of one carbon and CH2 group. So the different members, the different successive members, they differ by one carbon and two hydrogen atoms, okay. That means there will be a difference of a molecular mass also, right? So there will be a difference of a molecular mass, and the difference in the molecular mass will be one carbon and two hydrogen atoms, right? So that means carbon has an atomic mass of 12 and hydrogen 2 into 1, because 2 hydrogen atoms and 1 carbon, so there's 2 hydrogen atoms, and 1 is the atomic mass of hydrogen atom, 1 AMU, so therefore there will be a total difference of 14 AMU, right? So that means the two successive members of a homologous series, they also differ in terms of a molecular mass by 14 AMU, correct? So that means methane and ethane, there is a difference of 14 AMU, right? 14 atomic mass units. C3 and C2, again the difference will be 14 AMU. So there will be a difference in the molecular mass, like we find here a difference in the formula. The members differ by one carbon and the two hydrogen atoms, so there will be a difference of 14 AMU, because 14 AMU is the mass of one carbon and two hydrogen atoms, right? 14 AMU, correct? Now let's have a look at the homologous series of alkene family, right? Alkenes, okay. Again, the first member here is C2H4, second one is C3H6. So the two members differ by one carbon and two hydrogen atoms. So here again C3 and C4, difference of one carbon, two hydrogens. C4, C5, again a difference of one carbon and two hydrogen atoms. So that means the successive members differ by a CH2 group, and again the successive members differ in in terms of molecular mass also by an amount of 14 AMU, right? Because 14 AMU is the mass of one carbon and two hydrogen atoms, right? So let's have a look at another homologous series of alkynes: ethyne, propyne, butyne, pentyne, hexyne, heptyne, octyne, similarly nonine, decyne, right? And these members also, what we find here, that is a difference of a one carbon and two hydrogen atoms, right? C2, C3, okay, there's a difference of one carbon and two hydrogen atoms. And C3 and C4, they again differ by one carbon and two hydrogen atoms. So there again a difference of one carbon. So again here we find that the different members of the alkyne family, right, the homologous series of the alkyne family, they differ by a CH2 group again, and again there will be a difference of 14 AMU between the successive members, right, of the alkyne family. So in terms of molecular mass, they also differ by an amount of 14 AMU. Now what are the characteristics of a homologous series? First thing, each member of the series differs from the preceding one by an addition of CH2 group and by the 14 AMU, right, molecular mass. That means if you look at, suppose, the 14 methane, its molecular mass is what is the molecular mass? It will be 12 plus 4, that is 16. The the second member is C2H6, right? So there will be the 24 the carbon and 6 hydrogen atoms here. So this is actually 16 here. So now it will be 30, right? So it will be 30. The difference in the molecular mass is by an amount of 14 AMU. 16 for the first member, 30 for the second member. What will be the molecular mass for the C3H8? So you can say 30 plus 14, which is 44, right? So you can also count it here. You can just find it. C3, that is 36 plus here 8, which is 44, right? Okay, so this is the first characteristic feature of. Okay, now the second point is all members of a homologous series have the same general formula. For example, alkanes, they have a general formula of CnH2n plus 2. Alkenes, they have a general formula of CnH2n. So that means all the members of a homologous series have the same general formula. And the physical properties of the different members, there is some gradual change, right? Okay, so when we move from, suppose, methane to ethane to propane to butane, like that, right, in a homologous series, so physical properties may vary, they change, right, because the physical properties actually they depend on the molecular mass, right? And if the molecular mass increases, so there will be the increase in the melting point, boiling point, and other properties, correct? So physical properties change, and the change is there is a gradual change, correct, along a homologous series, but chemical properties will be same. For a particular homologous series, the chemical properties are same. Why? Because chemical properties are determined by the general, they are determined by the functional group, and the functional group is always same for a particular homologous series. Therefore, the different members of a homologous series, there is a difference in the physical properties, but the chemical properties will remain same, right? Fine. Now next point is, what is the significance of a homologous series? Okay, the first point, it's useful for the systematic study of the organic compounds, right? It's a more efficient way of studying the organic compounds. Okay, the second point is, it helps to predict the properties of those compounds of a series that are yet to be prepared, right? Because we can predict what will be the property of a compound that is yet to be prepared, right? So these are the two important applications of a homologous series. Hope you got the concept. Thanks for watching the video. Bye for now.